Good morning, my name is Parsa Jahanfar. I'm a junior network administrator here at SPB. I have prepared a presentation on principles and design of network systems. Introduction. Very warm welcome to the CEO and senior network administrator here at SPB. This presentation will consist of 4 principles of networks and networking protocol, followed by a discussion of array of network hardware and software available to the system developed. Network types is very important for SPB to recognize. We have wired network type. Pros are you simply have more control since you know what cable is connected to the network. Security, since the connection is made with cable, it's more secure. And speeds, then again, with cable you experience faster speeds. However, drawbacks for cable cutters. The more devices you have connected, it will cause cable cutters. Mobility, devices connected with cable or cannot move, they're immobile. Wireless connection. Pros are mobility. You can simply move around, have devices in offices, in rooms. It's more organized, since there's no need of cables. However, drawbacks can be security. When using a wireless connection, you are more vulnerable to attacks. And speeds. Devices in different rooms can have issues with the walls, and this can affect the speeds. Hybrid connection. Pros are it's flexible, it's designed and structured for the organization, for example here at SPB, to the different size and growth. And it's effective because it's designed to fit the requirements of SPB. However, drawbacks can be cable failures. If the main cable fails, it can affect the whole network, and it's quite difficult to install. It requires well-trained professionals, and it's quite complex. Network standards, we've got the OSI, TCP/IP, and 802.x models. These 3 different concepts are related to computer networking. This could be very helpful for SPB. The OSI model, pros are network support. The network support is supported by a wide range of device manufacturers. So, troubleshooting. Since each layer in the OSI is separated, it's far more easier to troubleshoot. However, drawbacks are adaptation. Many companies were not convinced to use this model due to the popularity of TCP/IP and effectiveness. Unlike TCP/IP, the OSI model failed to meet practical expectations. TCP/IP pros are compatibility. It's non-reliant on the operating system and it supports several routing protocols. Flexibility. It has designed to work with different network types and can be adapted to the specific needs of a particular network. However, drawbacks are it's difficult to set up. TCP/IP is a difficult model to set up and maintain. And security. Since it was designed to be an open network standard, it does not provide built-in security. 802.x pros are enhanced security. It consistently requires to be authenticated with all devices before they connect. Flexibility. 802.x supports a wide variety of authentication methods, including usernames, passwords, and biometric data. However, drawbacks are network performance. The authentication process used by 802.x can add stress to the network, which therefore can affect network performance. Limited device support. Some devices may not support 802.x, which can limit effectiveness as a network security solution. Network topology. Network topology refers to the arrangement of devices and connections in a network. It has significant impact on how data is transmitted and how the network performs. Different topologies have their own strengths and weaknesses. Any of these 3 could be used potentially here at SPB. There is star topology. All devices are connected to the central hub. as shown in the picture, and all data flows to this central point. Advantages are centralized control at the hub or switch. It allows for easy management. Fault isolation. If one device fails, it doesn't affect the entire network. However, the drawbacks are it relies heavily on the hub. If it fails, the entire network goes down, and its limited scalability due to the hub's capacity. Ring topology. Devices are connected in a circular fashion. Data circulates around the ring in one direction. So advantages are even data distribution. Data travels in a single direction, which reduces collisions. Bus topology. All devices are connected to a single cable. Data travels in both directions along the cable. Advantages are it's simple and cost effective for small networks, and it's easy to set up and expand. However, drawbacks are it's susceptible to cable failure. If the main cable fails or is damaged, the whole entire network is affected. And also, performance can degrade as more devices are added to this topology. Unicast, broadcast, and multicast communication. It's very important and is a very important method used potentially by SPE. Unicast, multicast, and broadcast are three different methods of communication in computer networks, each with its own purpose and characteristics. So unicast communication is one-to-one method where data is sent from sender to recipient. Multicast communication is one-to-many or many-to-many communication. Broadcast communication is communication from one to all. So it's a communication method where data is sent from sender to all devices on the network. Bandwidth requirements. A network's capacity to transport data from source to receiver. The speed of data transport increases with bandwidth, which will result in faster and more reliable connection. Network protocols. We've got three different network protocols, and we probably are using one of them here at SPE, IPv4. It's a system that assigns every device with a unique numerical address. It's like a phone number for computers. It helps them send or receive information on the internet. IPv4, however, is facing issues with capacity, with it being nearly depleted. Uses are internet connectivity and network management. IPv6, on the other hand, you could say is created as an upgraded version of IPv4, providing larger set of unique addresses for devices when talking to each other over the internet. Uses are security and expanding IP addresses, and it has far more security integrated system than the IPv4. HTTPS is a protocol that makes sure your online communication and data are safe. It's like a secure mail for the information you send or receive on the internet. It's commonly used for shopping websites and secure websites, and also protecting your personal information. Uses are secure data and verified website authenticity. Operating principles of networking devices. Here at SPE, we could be using any of these, very important. Routers. Routers route data between networks based on IP addresses, manage routing tables, and provide security through access control. Switches forward data within local networks using MAC addresses. Firewalls filter and monitor network traffic to prevent unauthorized access and security threats with various techniques. IoT gateways connects and manages the flow of information between IoT devices like sensors or cameras, and this internet or central system helps devices talk to each other on or off the cloud, making it easier for you to control and monitor. Repeaters. Repeaters amplify and retransmit signals to extend network reach, overcoming signal degradation in long-distance connections. And bridges. Bridges connect and filter traffic between network segments using MAC addresses. Network server types. So 4 different network server types: domain servers, web servers, and file servers. Also database servers. Domain servers such as DNS servers resolve human-readable domain names into IP addresses. They maintain DNS records and distribute them to clients. Web servers. Web servers store and deliver web content such as HTML pages, images, and multimedia files. File servers. File servers store and manage files that can be accessed and shared by network users, providing centralized file storage and access control. Database servers host databases and manage data storage. Access permission. Access permissions determine who can access specific network resources and what actions they can perform, such as read, write, and delete. They are a root aspect of network security and access control. So, how workstation hardware depends on relevant networking software. Processors. The CPU's processing power impacts the performance of networking tasks, such as data encryption and data compression. Operating system. Networking software must be compatible with the OS, utilizing its capabilities for network management and communication. Memory, also known as RAM, and network buffering. Workstations with RAM can store more data in memory, which is crucial for networking tasks. Buffering networking data helps in managing network traffic efficiently. Network interface cards, also known as NICs, and device drivers. The type of capacity of NICs determine how devices connect to the network. Networking software relies on device drivers to interact with the NICs. Compatibility with the NICs and drivers and software is crucial for seamless networking function. Application software. Application software running on workstation depends on networking software to communicate with remote servers or services. In conclusion, we have now investigated the fundamental components of networks and networking protocols. The growth of the business relies on a well-designed network that allows data and communication to flow consistently. It is crucial for the business to analyze and react accordingly to the constant changes of networks. Upgrading the necessary networks to ensure safe and secure and fast networks. This will allow SPV to remain competitive and to incur fortified network infrastructure. Thank you, and thank you for your time.